Hello everyone. Today we are going to discuss some of the doubts sent by students. Okay. First one is that four gases like hydrogen, helium, methane, CO2. Okay, these four gases have Henry's law constant, that is KH values given here. What 69.16 for hydrogen. It is for hydrogen given, and 144.97 for helium, and 0.413 for CH4, and CO2 has 1.67. 1.67. So these are Henry's law constant values for different gases given. The gas which is more soluble in liquids, the gas which is more soluble. So the solubility is inversely proportional to what? KH, Henry's law constant. So which one has least here? CH4 has least. So when least KH value is there, the solubility will be highest. So this one keep in mind. And also the solubility is inversely proportional to temperature. Solubility of gas is inversely proportional to what? Temperature. When temperature increases, solubility will decrease. Therefore, we can say KH value and temperature both are directly proportional to each other. When temperature increases, KH value increases for a given gas. Next, 100 ml means volume is given. 100 ml of O2 gas. O2 gas gram molecular weight, how much? Gram molecular weight 32 grams per mole. And volume is given what? 100 ml given here. Diffused through a porous spot. Porous spot. Here, what is rate of diffusion? Rate of diffusion is equal to volume of oxygen diffused divided by time taken. Time taken by oxygen gas. Volume of oxygen diffused by time taken by oxygen diffused. Okay, O2 means oxygen here. Through a porous spot. Porous spot means small hole in 50 seconds. So it is what now? Time taken by oxygen gas. T of oxygen gas. Time taken by oxygen gas for diffusion. How long will it take for 500 ml of CO2? How long it will take for CO2 means T of CO2. Okay, time taken for CO2 is what? What is volume of CO2 given here? Volume of CO2 is given 500 ml to diffuse under similar conditions. And what is gram molecular weight of CO2? Gram molecular weight of CO2 is what? 44 grams per mole. Okay, here you take second gas CO2 and first gas as what? First gas oxygen you take. First gas oxygen, second gas CO2. Now here what is the formula here? R1 by R2. Okay, is equal to under root M2 by M1. Under root M2 by M1. So here under root M2 is what now? First you take here. So under M2 is what now? Here CO2 44, M1 is 32. And R1 how to take now? Here tell me. R1 value how to take? V1 by volume of oxygen by time of oxygen divided by again what now? Here by what we have to take? Volume of CO2, volume of second gas by time of second gas. So here in place of R1 what we write? V1 by T1. In place of R2 what we write? V2 by T2. So here V1 is what? V1 is 100 ml. V2 is what? V2 is what? 500 ml. V2 is 500 ml. And M2 is what? 44. M1 is 32. So this formula we have to apply here. So what we have taken now here? V1 by T1. V1 by T1 into T2 by V1. T2 by V2 is equal to under root 44. 44 for CO2 by 32 for oxygen. So here V1 is how much here? V1 is 100 ml and V2 how much? V2 500 ml. And T1 for oxygen how much given? T1 for oxygen time taken is 50 seconds. And T2 we have to calculate. T2 of CO2 we have to calculate. Okay, take screenshot and calculate T2 value for this. This is one of the problems. Okay. Next, gases van der Waals constants. Okay, for gases, for different gases, they have given what? Van der Waals constant B value given here. Okay, now for NH3, how much it is? 0.371. CO2, how much? 0.0427. C2H4 is ethene. And C2H6, ethane. Ethene, 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 CO2, NH3. Four gases given here. Which of the following gases is most incompressible? Most incompressible. Incompressible means what now here? Cannot be compressed easily. Cannot be easily compressed is what now here? CO2, because the B value is what? Very small here, 0.04. but here 0.05, 0.06, 0.3. So it is least value here. So least value for what now? CO2 here. For CO2, B value is least. When B value is least, what happens? It cannot be easily compressed. Easily it cannot be compressed. So which of the following gases is most incompressible in nature? They asked here. Incompressible nature means what here? CO2 has less value of B. Lesser the value of B, it is more incompressible. Okay. Next, here 60% of H2 and 40% of O2. Here volume fraction given here. So volume fraction of H2, how much here? Volume fraction of H2. Volume fraction is nothing but mole fraction here. We take here. Volume fraction of H2, how much? Of H2 is 60% per century, per 100. So 6 by 10. 6 by 10 is what now is a fraction of hydrogen gas. And fraction of volume, fraction of oxygen, how much here? 40%. 40% means 4 by 10. Okay. So 2 by what? 5. So like this fraction we have taken. Volume fraction of H2, volume fraction of oxygen are present in a mixture. In a mixture of two gases, we have oxygen gas and hydrogen H2 gas. At a pressure of what now? 100 mm. So total pressure is what now here? Total pressure is what? 100 mm. P total. What we take here? P total. So total pressure of mixture is how much? 100 mm. 100 mm. Now pressure exerted by H2. Only H2 means partial pressure. They asked here. Partial pressure of H2 is equal to what? Volume fraction. Otherwise, mole fraction we can take. Here, mole fraction we don't know, na? So we take volume fraction into total pressure. Volume fraction into total pressure. Now, volume fraction of H2, how much more? Volume fraction of H2, 60%, na? 60%. Okay, 60% into what? Into total pressure, how much? 100. Okay, that is what now here. It is 60. 60 mm will be what now here? The partial pressure exerted by H2 gas. Partial pressure means what now? Mole fraction into total pressure. Na? Like that here we can also take volume fraction into total pressure. Volume fraction into total pressure is equal to partial pressure. Partial pressure of only H2 they asked here. H2 they have asked it. Is that clear? Next. Compressibility factor Z for a given gas is what now? PV by nRT. Z is equal to PV by nRT. Okay, select the correct statements. Here they ask the correct statements. Correct statements from the following. Sometimes they ask you to find out incorrect statements. Sometimes they ask you to find out correct statement. What they have asked, we have to round off first. Here, correct statement we have to find out. Now, Z is equal to 1. Z is equal to 1 for ideal gas. Okay, only. Means for ideal gases, Z value will be only 1. That is right statement. Correct. And at normal temperature, generally, Z value greater than for one hydrogen. Z value greater than 1 for hydrogen means what? Now positive deviation will be shown here. Always hydrogen and helium will show what? Positive deviation only. Z value will be greater than 1 only for these gases, hydrogen and helium. So it is also true statement. And next one, for CO2 gas, Z value greater than 1 at moderate pressure, means at not high pressure. At moderate pressure above its Boyle's temperature. Boyle's temperature formula what? TB is equal to A by RB. A and B are what now? Van der Waals constants. Capital R is universal gas constant. So TB is Boyle's temperature is given by A by RB. So now what they are saying, Z value is greater than 1 for CO2 they are saying at moderate pressure above its Boyle temperature. No, Z value will be less than 1 for CO2. It is not correct. It is not correct statement. Z value will be less than 1. CO2 will be showing what initially negative deviation. After that, at very high pressures only, it will show what positive deviation. That's why we have to say it is wrong statement C. And next one is what now? Z value greater than 1 for real gas. For real gas at very high pressure. Z value greater than 1. Z value greater than 1 for real gas at very high pressure. The correct answer is what? Now, which one here? D is also correct statement. Z value will be greater than 1 for real gas at very high pressure. At very high pressures, Z value will always be greater than 1 for any real gas. For any real gas like CO2, NH3, H2, any gas will be showing what? Positive deviation. Z value will be more than 1 at very high pressure. At very high pressure. Is that clear? So ABD will be answered. Next, in a gaseous mixture at 20 degrees Celsius. So what is temperature given here? 20 plus 273 Kelvin. 20 plus 273 Kelvin. The partial pressure of a component gas means the partial pressures of component gases are as follows. Now hydrogen partial pressure, how much here? Partial pressure of H2 and partial pressure of CO2 and partial pressure of CH4 methane, partial pressure of ethylene. Ethylene means what now here? C2H4 ethylene gas. Okay, it is given partial pressure of ethylene 130 and partial pressure of methane is what? 320. Like this given. The volume fraction of hydrogen is what? A hydrogen partial pressure, how much is given here? Partial pressure of hydrogen 200 mm given. So what is the formula it will in the previous problem? Partial pressure of hydrogen is equal to volume fraction, like mole fraction. Volume fraction of hydrogen, volume fraction of hydrogen into total pressure. Total pressure. Now P total, what generally according to Dalton's law of partial pressure, P total is equal to what now here? Partial sum of the partial pressures of all gases. Now what are the gases here? 200 mm, 200 mm of H2. Then next one, 150 mm of CO2, partial pressure of CO2 plus partial pressure of methane plus partial pressure of ethylene 130. So sum of all these will be equal to P total. Sum of all the partial pressures is equal to what? P total. Now P total we know. Sum of all these here. Sum of all these equal to P total here. Then volume fraction we are asked to calculate. This volume fraction we have to calculate. And the partial pressure of hydrogen, how much is given here? 200 mm. 200 mm. So 200 mm is equal to volume fraction we need to calculate into P total is what? Sum of all these values. Like this we get what now here? The mole fraction or volume fraction of hydrogen gas. Okay. Next, a vessel contains equal number of moles. Equal number of moles. So equal number of moles means the same number of moles should be taken here. Let it be 1 mole and 1 mole, or 2 moles and 2 moles, or 10 moles and 10 moles, whatever it is. So equal number of moles of what? Helium and methane. So helium gram molecular weight how much? 4. And methane gram molecular weight how much? 16. CH4 na methane 16. For helium 4. So M1, M2, two gases given here. Equal number of moles they give. Number of moles of first gas is equal to number of moles of second gas is equal to some x moles. Let it be x moles or 10 moles or 100 moles, whatever it is you take. 1 mole you take better, like that. Through a small orifice. Orifice means what? Small hole, small pore, P-O-R-E, pore, small hole. The half of the gas effused out. Half of the gas effused out. Effused out means diffused out. It has gone outside of the vessel. The ratio of the number of moles of helium and methane remaining in the vessel. Remaining means leftover. Remaining means what here? How much gas of helium left over, how much gas of methane left over, we have to understand. What is the formula first? R1 by R2 is equal to under root M2 by M1. Under root M2 by M1. That is equal to M2 is what now here? 16. 16 by M1 is how much? 4 here. M1 is 4. So that is the root, square root of 4. So R1 by R2 is equal to square root of 4. That is equal to 2 here. So R1 by R2 is equal to what? 2 by 1. 2 by 1 we take here. Is that clear? Now here R1 by R2 is the rate of diffusion of first gas by rate of diffusion of second gas here. That is 2 by 1. 2:1. But they asked about how much leftover they asked here. Leftover means reverse. Leftover means reverse. 1:2. Leftover remaining will be 1:2. But diffused will be 2:1. So which gas is diffusing faster? The first gas. Because first gas is lighter gas, na? Less molecular weight is there than methane. When lighter gas is taken, it will diffuse faster. It will diffuse faster. That's why it will be leftover less. Helium gas is lighter gas, so diffuses faster. That's why leftover less. So 2:1 is what? Rates of diffusion. But leftover what? 1:1. 1:2. Reverse. Is that clear? So 1:2 will be answer here. So rates of diffusion, if they ask you, R1 is to R2, if they ask you, 2:1. But if they ask you leftover, 1:2. So that concept you have to understand here. Next, a solution is obtained by mixing 300 grams of 25% solution So solution 1 it is. What is solution 1? Solution 1, how much percentage given? 25% by mass given. It is what W by W percentage. W by W percentage 25% given. The weight of first solution how much? 300 grams. So weight of solution 1. Weight of solution 1 how much ma? 300 grams. And what is W by W percentage? 25%. And it is what now? Weight of second solution. Weight of solution 2. And what is the W by W percent of second solution? 40% by mass, means W by W percent. Calculate the mass percentage. Again, W percent we have to get. W by W percent of the resultant solution. Of what? Resultant solution. So resultant solution means what now? What and what are mixed here? Total weight will be what? 300 grams of 25% solution. 40% of 400 gram solution we mixed here. So what will be this now here? What will be weight of first solute? Weight of solute 1. Weight of solute 1 is equal to how much percentage here? 25%. 25% of 300. 25% of what now? 300 will be equal to what now here? 3 into 25 how much? 75 grams. 75 grams of first solute. And weight of second solute. Weight of solute 2 is equal to what? Now, what is the percentage weight percent of second solution? 40%. 40 per century. Percent means per century. Into what is the weight of second solution? 400. That is equal to here 100, 400. So 4 into 4. Here 4 into 40, 160 grams. 160 grams of what? Second solute. Now add these two. 160 plus 75. 160 plus 75 will be total weight of solute. Okay, what is total weight of solution? Total weight of solution 300 plus 400. Total weight of solution is what? 300 plus 400. So total weight of solution is known and weights of solute we know. Okay, so now here 70 plus 160 weight of solute by weight of solution into 100. So what is W by W percent? W by W percent of resultant solution. Resultant solution is equal to weight of solute. Total weight of solute by weight of solution. Total weight of solutions. Total weight of solution. Now total weight of solution formed how much? 400 plus 300, 700. What is the total weight of solutes? 75 plus what? 160. Like this we have to get it. Come on. So weight of total weight of solutes by total weight of solution should be giving what? Mass by mass percentage. That is mass percentage. Okay. Next, the mole fraction of ethylene glycol formula is given C2H6O2. Now C2 means 12 plus 12, 24 plus hydrogen 6 plus oxygen 2, 32. So what will be gram molecular weight now here? 24 plus 6, 30, 30 plus 32, 62. Okay, so 30 plus 32, 62 grams per mole is gram molecular weight of ethylene glycol we have understood here. In a solution containing 20% by mass, 20% by mass meaning what? W by W percentage. W by W percentage is given what? 20. That means what now here? 20 grams solute. 20 grams solute. This is what now here? Solute. Ethylene glycol is what? Solute here. 20 grams solute in 100 grams solution. 100 grams solution. So 100 grams solution here. In 100 grams solution, how many grams solute is there? 20 grams solute is there. Right, ma? That means here weight of solution meaning what? Weight of solution means what? Weight of solvent plus weight of solute. Together how much we understood? 100 grams. Then weight of solute already how much we understood? 20. Then weight of solvent W1. That is weight of water here. Weight of H2O. Weight of solvent water is equal to what? 100 minus 20, 80 grams. 80 grams is water, H2O. Is that clear, ma? Now they asked about mole fraction. Mole fraction of solute they asked it. Mole fraction of solute is equal to number of moles of solute by number of moles of solvent plus number of moles of solute. This one they asked here. Now your X2 they asked. X2 means what? Mole fraction solute they asked. Now your weight of water, how much here? W1, 80 grams. Now here tell me now, N1 means number of moles of water, how much here? Weight of water by gram molecular weight of water. Next, N2 is number of moles of ethylene glycol, number of moles of solute. A weight of solute, how much here? 20 grams. 20 grams of solute, 20 grams of solute by gram molecular weight, how much we calculated? Here C2 means 24, H6 means 6, O2 means 32. It will be what now here totally? 30 plus 32. So it is 62. So by 62. So like this we get N1 value, N2 value first. After that we have to substitute in X2 formula. N2 by N1 plus N2. This one will be answered. Is that clear, ma'am? So like this mole fraction they asked here. They have given you what? Weight by weight percentage, mass by mass percentage is given, and they asked you to calculate what? Mole fraction. Like this we have to understand. Is that clear? Next. If N2 gas is bubbled through water at 293 Kelvin, which gas is bubble here? N2 gas is bubbled through what? The water at 293 Kelvin. How many millimoles? Number of millimoles, number of millimoles of gas. So number of millimoles of N2 they asked here. Number of millimoles of N2 gas would be dissolved in 1 liter water. 1 liter water means how many ml, ma? 1000 ml water. 1000 ml water. So 1000 ml water we have taken. 1000 ml water is equal to how many grams? 1000 grams water, remember. Why? For water, what is density? 1 gram per ml. 1 gram is equal to 1 ml. So 1000 ml is equal to 1000 grams of water. So 1 liter of water means 1000 grams of water. When water is 1000 grams, what will be number of moles of water? Number of moles of water will be equal to formula what? Given weight of water by gram molecular weight of water. So given weight, how much we understood? 1 liter means 1000 ml. 1000 ml means 1000 grams. 1000 grams by 18 is gram molecular weight. So it is 55.55 moles H2O. 55.55 moles of H2O we have to understand here. 1 liter water means. Okay. And we have to calculate number of millimoles of nitrogen gas. Okay. That will be dissolved in 1 liter water. Assume that nitrogen exerts a partial pressure of 0.987 bar. What is the partial pressure of nitrogen given? 0.987 bar. Given that Henry's law constant for nitrogen at given temperature 293 Kelvin is 76.48 kilobar. A kilo they gave. Kilo means how much more? 1000. So what is this KH value given here? KH value is equal to KH of nitrogen. KH of nitrogen is equal to a 76.48 into 1000 bar. K means kilo. Kilo means 1000. So if you multiply with 1000, what happens? 46480. So 76480. That means what? 76,480 bar. 76,480 bar will be KH value, and partial pressure is given 0.987. 0.987 is partial pressure of nitrogen, and the KH value given in kilobar, but we have taken in bar. Okay. Next one, they asked you to calculate now number of millimoles of nitrogen that would be dissolved in 1 liter of water. They asked you. First formula, Henry's law formula. First, what you have recall? Tell me. Henry's law equation. What first? Partial pressure of gas. Here, which gas is mentioned? Nitrogen. Partial pressure of gas is equal to KH, Henry's law constant value, into mole fraction of the gas. Mole fraction of the gas. So mole fraction of the gas, KH value, PP. What are given here? Partial pressure is given to you, 0.987 is given to you, and KH value given to you. Now can we calculate the X of gas or not? Mole fraction of gas we can calculate. X means what here? Mole fraction. Mole fraction of N2 gas we can calculate first. See here, mole fraction of N2 is equal to 0.987 by 76,480 bar will be equal to approximately 1.3 into 10 power minus 5. 1.3 into 10 power minus 5 is what now? X N2, mole fraction of N2. They asked what now? Number of moles. Number of moles of N2 they asked here, millimoles. So we need number of moles of nitrogen in water. Now when nitrogen is dissolved in water, nitrogen acts as what? Solute. Nitrogen acts as what? Solute. And the water acts as what? Solvent. When nitrogen gas dissolves in water, nitrogen acts as solute, water acts as what? Solvent. That's why now here, X of nitrogen formula what now again? I'm erasing this one. Once take screenshot of this. Screenshot of this page you take once. I will erase everything. Yeah. Now see, listen. Now, what I'm saying, now Xn2 we got. What we got? X of nitrogen, mole fraction of nitrogen we got. Mole fraction of nitrogen formula what? Number of moles of nitrogen gas divided by, again, number of moles of nitrogen gas plus number of moles of water. Number of moles of water. Now, number of moles of water, how much we got? 55.55 moles we got now. Because 1000 grams by 18 is equal to 55.55 moles we got. This means it is number of moles of water. Now Xn2 how much we got here in this above equation here? 0.987 by 76,480 means approximately it is equal to 1.3 into 10 power minus 5 we got. 10 power minus 5 we got what now? Mole fraction. Now N of N2 we have to get. Number of moles of nitrogen we have to get. This one we have to calculate. But they asked moles or millimoles. They asked millimoles. Now generally we know that 10 power minus 3 moles equals to 1 millimole. 1 millimole formula, 10 power minus 3 is nothing but milli, na? So 10 power minus 3 mole equals to 1 millimole. Here we get some X moles here. X moles of nitrogen we get, suppose here. X moles of nitrogen we get from this formula. After getting X moles of nitrogen here, if 10 power minus 3 moles equals to 1 mole, 1 millimole, then X moles equals to how much? Now X into 1, X by 10 power minus 3 means what? X into 10 power 3. X into 10 power 3 will be answer now. Here we get some X value here. After getting this X value, nitrogen number of moles we get, that number of moles of nitrogen into 10 power 3 will be answer now here. Here we understand 10 power minus 3 moles equals to 1 millimole. The next moles will be equal to how much? Cross multiplication. 1 into X by 10 power minus 3 means X into 10 power 3. X into 10 power 3 millimoles. Answer. Okay. So it's about Henry's law concept. Henry's law concept. Next. So the same thing. Now here, how many grams of CO2? Now here not moles. They asked what now? Grams. How many grams of CO2? Means weight of CO2 they asked here. Mass of CO2 will be what? Not number of moles. In previous equation of Henry's law, nitrogen number of millimoles they asked. But here CO2 number of moles they are not asking. They are asking weight of CO2. How many grams of CO2 gas is dissolved in a liter bottle of carbonated water? Here 1 liter means how many ml? 1000 ml. 1000 ml water is there here. 1000 ml water. So 1 liter means 1000 ml water. In 1000 ml water, how many grams of CO2 will be dissolved if the manufacturer uses a pressure of 2.4 atm. 2.4 atm he has used in the bottling process at given temperature at 25 degrees Celsius. He used how much pressure on the CO2 gas to dissolve in water? 2.4 atm he used. It is pressure. Next one, given kH of CO2. Henry's law constant of CO2 is given how much? 29.7 atm they give. Okay. Now here there are what they have asked is CO2 grams. They ask how many grams of CO2 dissolved. They ask here. Henry's law constant how much here? 29 moles per liter at same temperature. This is what they asked. Weight of CO2 we have to get. But the pressure of gas they used here 2.4. What is Henry's law constant? 29.76. That point keep in mind. Now here see, according to Henry's law, partial pressure is equal to what? Partial pressure of gas is equal to Henry's law constant into solubility. Solubility nothing but what? Mole fraction only. Solubility nothing but mole fraction. So solubility is the solubility in moles per liter. This will be mole fraction or solubility we take. If we take S solubility, we take what? Moles per liter. Solubility in moles per liter. Now KH is the Henry's law constant, we know. And P is what? The pressure of gas in ATM. Pressure of gas in ATM, how much is given? 2.5 ATM given. KH value given. Then solubility we can get. Substitute the values in the above expression, and pressure of gas is given 2.4 ATM. 2.4 ATM, and KH of the gas is given these many ATM 29.76, and solubility we can calculate in moles per liter. Our solubility we got what now here? 0.0806 m, means what now? 0.0806 moles of CO2, in 1 liter. In 1 liter. In 1 liter of solution, how many moles of CO2 present here? 0.08 moles of CO2 is present. That's 0.0806 moles of CO2 in 1 liter. In 1 liter of solution. So this corresponds how much weight now? Number of moles into gram molecular weight. Gram molecular weight of CO2 how much? 44. 44 into number of moles how much now? 3.52 grams. So Henry's law equation what now here? We can take pressure of gas is equal to KH into solubility. Pressure of gas is equal to KH into solubility. Otherwise, what we take? Another formula what? Partial pressure of gas is equal to KH into mole fraction of gas. Mole fraction of gas, partial pressure of gas. It is one equation of Henry's law. It is another equation of Henry's law. Is that clear, ma? Here only CO2 gas is dissolved in water, no mixture, pure CO2. That's why for single gas we have to take this one here. This equation is for what? Single gas. For single gas CO2 we have taken this one equation. And this equation will be used in which case? For mixture of gases. For mixture of gases. For mixture of gases, what we take formula? Partial pressure of gas is equal to Henry's law constant into X of gas, mole fraction of gas. It is for mixture of different gases, 2 or more gases. If we take air is the mixture of nitrogen, oxygen, CO2. So for air, we use this formula. This formula we use for mixture of gases. But here we are dissolving only CO2 in the problem. The given problem, only CO2 gas is dissolved in water. Only single gas we have considered. That's why we use formula what? Pressure of the gas equals to Henry's law constant in the solubility we take. The solubility we get in moles per liter. In 1 liter, how many moles we have to understand here. That is the difference between mixture of gases and single gas. Is that clear, ma? Next, H2S, hydrogen sulfide, a toxic gas with rotten egg-like smell. Rotten egg smelling gas. It is rotten egg smelling gas. That is H2S. Is used for the qualitative analysis. Okay, in qualitative analysis process, we use what? H2S gas. Okay, if the solubility of H2S in water at STP is 0.095 molar. Okay, here you take this one molarity, molal, not molar. 0.195 molal. Small m we take, small m. Then Henry's law constant is what? Means KH they asked here. KH is equal to what? Okay, ma? So what is given here? The molarity given here. Molality given. Concentration is given at STP. They asked KH value. Okay? Of here. Now given molality, LITY. Molality. Molality is 0.195 molal. What is molal? Small m means molal solution. Now molality is equal to what? Number of moles of solute. Number of moles of solute means N2 by mass of solvent in kilogram. Mass of solvent means what? Now W1 in kg. W1 in kg. So number of moles by weight of solvent in kilograms. It is molality, LITY. Okay, molality small m. Next, let us consider mass of water 1 kg. 1 kg water you take, suppose here. Now, number of moles of solute. Number of moles of solute formula what? Molarity into mass of solvent. Why? Molarity formula what? Number of moles by molality. Sorry, again. Molality formula what? Molality is equal number of moles by mass of solvent. Molality. Molality. Formula what, ma? Mass of means number of moles of solvent, number of moles of solute by what? Mass of solvent in kg. It is molality formula. Now from this number of moles, how to take number of moles of solute is equal to molality into weight of solvent. Molality into weight of solvent. It is L here. Remember, this is L. Molality into mass of solvent. So molality, how much is given? 0.195 molal solution into what is the mass of solvent here? 1 kg water. 1 kg water we have taken. Therefore, 0.195 into 1, that is 0.195 moles. 0.195 moles. Okay. And next one, what here? Molecular mass of water, how much? 18 grams per mole. Now, number of moles of water, number of moles, how to get mass by molecular mass. Mass of water, how much? 1000 grams. 1000 grams means 1 liter. Molecular mass of water, 18. 1000 by 18, 55.55 moles. That is the number of moles of water. Number of moles of water. Here, since 1 kg is equal to what? 1000 grams. Okay, is equal to 1000 ml. 1000 ml, that equals to 1 liter. 1000 ml equals to 1 liter water. Like this. Mole fraction of H2S gas. Mole fraction of H2S gas is equal to what? Number of moles of H2S divided by number of moles of H2S plus number of moles of water. Number of moles of H2S by number of moles of H2S plus number of moles of water will be equal to what now? Mole fraction 0.0035. 0.0035 is the mole fraction of H2S gas in water. At STP, okay, at STP we have understood here. Now pressure is equal to now 0.987 atm. Pressure is equal to 0.987 atm. 1 bar is equal to what? Since 1 bar at STP. 1 bar at STP is equal to what now? 0.987 atm. It is a conversion of bar into atm. According to Henry's law, now partial pressure is equal to Kh into mole fraction. Partial pressure is equal to mole fraction, Henry's law constant into mole fraction here. From the Henry's law, they asked you to calculate. The Henry's law is equal to what? Partial pressure by mole fraction. So partial pressure of the gas is given by mole fraction, we calculate. Mole fraction of gas. So mole fraction of H2S. This one we calculated. Mole fraction of H2S, and it is what? Partial pressure of CO2 of gas, of H2S gas. Partial pressure of a gas by mole fraction of gas is equal to Henry's law constant Kh. Is that clear? So this way we have to understand the concept. So these are all things we have to understand without any confusion. Okay, ma? So remaining we'll discuss in the next class. Next video I will put it. Today go through this. Mainly Henry's law problem only most of you are asking doubts, right? Okay. Bye. Good day.